Welcome back everybody, my name is Dustin. In our last video, we created our first triangle and then we created our first quad. In today's video, we're going to go over how to load textures and draw them to those quads. So let's go over a few of the things that I'd like to cover in today's video. Alright, so today we're going to go over how we're going to load and draw textures in our game. To load the textures, we're going to be using a library called Soil, or simple OpenGL Image Library. This library is based on SDB image and has been extended to load different files. We'll also be adding this as another static library in our project. Here's a little example of how we're going to be loading the texture using Soil. This will load the file that we send in as an argument and will determine the height, width, and number of channels that the texture has for us. The channels would be the RGB or RGBA values, so it could be 3 or 4 in this case. So let's take a look at texture coordinates. Most textures are a 2D array of various color values. The individual color values are called texture elements or texels. Each texel has an address and they are in something called texture space. These are usually called UVs and they are similar to your X and Y coordinates on the Cartesian plane. Each texel coordinate must be mapped to each vertex and has a range of 0 to 1. If you look at the image here, in OpenGL, the texture coordinates start from the bottom left corner and go outwards. If you used SDL before, this is the opposite to what we're used to there. This is the array of vertices that we created in the last video. However, we've added 2 more float values for the texture coordinates. So we'll have to add these values to our shader as well as enable them for use. This makes use of the entire texture. Top left 0, 1, 1, 1 for top right, 1, 0 for bottom right, and 0, 0 for bottom left. If you take a look here, this ends up making use of the entire texture for this particular quad. However, what if you don't want to use your entire image and you have multiple images on your one texture? Well, that's when you create sprite or tile sheets. You can create sprite and tile sheets by adding multiple images into one texture or a single texture. This is more efficient because then you can have less textures in memory and we can just reuse the exact same texture and just adjust the coordinates. So how would we use this sprite sheet? Remember that texture coordinates are from 0 to 1. So we also will need the width and height of the entire texture. We'll also need the desired size of the tile or sprite. Let that be 16 by 16, 32 by 32 pixels, etc. So take this image here for instance. As you can see, the image has a width and height of 32 by 32, and there are 4 separate textures. The textures in this case are equally sliced into 16 by 16 tiles. We can make a handy struct to get the desired UV values that we need for this. The struct will have a U, a V, a width, and height members. Once we have this struct in place, we can create a small lambda function that will help us generate the desired UV values. We can find the width and the height of the UVs by taking your desired sprite or tile width and dividing it by the entire width of the texture, and the same thing for height. That will give you a value between 0 and 1. Now we should put checks in here to make sure that the sprite width going in is not larger than the width, but this is fine for now. Then we base the U and the V value based on the start position of our image that we want. And when we have that start position, we multiply it by our already just calculated UV width and UV height. So say we want this blue hexagon right here. Well, where is it on our texture? So it's 1 over and 0 up. So it'll be 1 times UV width, and that will give you your value, and then this one would end up being 0 because it would be 0 times UV's height. And then you send in the 16 and the 16 for your sprite width and sprite height. So if we do this, that should generate the correct values for us to get this sprite here. But before we can get this, we have to adjust our vertices to use these newly generated values. So this is this here. So as you can see here in the top left, we're using the U value and the V value plus height. So if you come here, it's UVU right there, so like your 0, and then this is going to be for top left, so it's UVV, which is also here, plus the height. Does that make sense? So it'd be like 0 and 1, so 0 and 1, pretty similar. So we want that's for our top left, and for our top right it's the same thing, so it's UVU plus UV width, and then UVV plus UV height. It gives you the top right corner, etc. If you can do the same thing for the bottom right and the bottom left, it'll give you the same results. So how about we go over that in the code and how to do this. Let's get started. Alright, so we're going to be using Soil as a static library. So that's the first thing we're going to do here. So we're going to come here and we're going to start a new project. We're going to come here and we're going to add new project. And it's just going to be an empty project. And we're going to just call it Soil. create. Soil is created. So now just go here, go to your properties of the soil, and we're going to change this to a static lib. And just to keep everything consistent, change this to C++ 20. Okay, so now that we have those, we're going to want to go to download the soil library. So we just go here, we go just type in download soil, and then we go to, I just go to the first one. There's multiple that you could use. And then I just go here and we go to your 5 tags. Let's get the latest release. And we want source code zip. Once that's done downloading for you, you can extract it. This is just what I do. You can do it other ways if you want. If you want to clone the repo or whatever, you can do that as well. But this is how I'm going to do it. So you just extract the files here. And I just want this here. They include the source, and we'll grab the license as well. So we'll just cut this from here and then open up your, where you put your files here. So go to wherever you keep your project, your solution, go to soil and just paste this inside. So that's there now. So let's go back to our project. So now that we're in our project, we just go here, and let's not make the mistake we made last time. And we want to make sure we include all these files. So just highlight these, include in project. All right. And then I want to include this as well. So we go here, go to our properties again, and our VC directories, and I want to go to include directories. And we want to go to, oh, we're already in soil. I want to go to soil, include, and I want to do that. And if you remember, it's solution dir or solution directory, one back. Okay, apply. And let's try to build. And we can do that by going to project only, build only soil. All right, so it's saying that there is no such thing as this, which it should be there. That's another problem right there. CRT, secure no warnings. So that's right away. So where is it? It's saying it doesn't see that. It should. But right away, we should go into here, go to C++, and see where it says preprocessor. So we just want to go semicolon, and then CRT, secure no warnings. Okay. And let's try to build again. That should get rid of that at least. And then we just do project only, build only soil. It's not seeing it. I must not have. I don't want this Scion2D. We want to get rid of that. There, that should work. Yay! So now it sees it. We have our secure no warnings. Let's try to build again. And project only, build only. I swore I put it in. Oh, it must not have saved it. CRT, secure, no warnings. Yeah. And last time. Build. Yay, build succeeded. Okay, so now we can close that. We don't need to see that. Now we want to link that in our editor. So we just go to our editor and go properties, not properties, sorry, editor, add, reference, soil. We want soil, And we also want to put that into our VC directories. I'll just put it at the bottom here. Soil include. Get rid of all of this. All right, now we should be able to include soil in here. So let's get rid of all of this. We don't need that. We're only going to do everything in main right now. We will abstract everything away eventually into their own files, but right now we're just going to do it all in main, just for testing purposes, get our feet wet. So right here, let's see if we can include soil now. So include soil, soil.h. Awesome. So let's quickly go over the load texture function that I want to put in there. So it'll just be a bool. Load texture. This will take in a const string. And that'll just be our file path. It'll take in the width, the height. We're sending it in as a reference because I do want to change these values, and if it's going to be blended or not. So we'll make a channels. This one doesn't need to be used outside of the function, so we're just going to make it local. And then we can go unsigned char pointer image is equal to soil load image that takes a C string and it takes the width, the height, the channels, and it takes in why is that still red? Oh, soil load image. All right. So what this is just your file name. Or the image file to be loaded. Oh geez. This is the width, clearly. The width of the image. Height. The height of the image. The channels. And this is the number of channels. So your RGB or RGBA values. And then the force channels. Now, we're not going to be forcing the channel, so this will force the channels to, or force the channel count, force it to be something else, and we're not going to be doing that, so we just go to load. So now, we just want to check to see if the image is successful, and that's just if not image. Soil failed to load image, and we'll give the file path. And then we'll get the error from soil. So soil last result. And then we'll return false and leave the function. However, if it works, we want to get the format, so we'll just say GL int format is equal to GL RGBA as default, and then we'll switch based on the channels that we got from soil, and that'll just be case 3 format is equal to GL RGB, and case 4 will be RGBA. Now we're going to want to set our texture parameters. GL text parameter I, and that's GL texture 2D, GL texture wrap S, and we're going to do GL clamp to edge, and we're going to do the same for T, texture wrap T. So if you go to Learn OpenGL, they'll explain more here about what clamp to edge is and your texture wrap. Then we go if not blended. So if we're not blended, I'm going to want to use the nearest. The nearest will make it more pixelated. So if you have a pixel image, it'll look more pixely. Where if I use GL linear will blend them together basically. So it'll make each pixel look more blended, more smooth, and it won't be as pixelated. So we can take this here, and then we just say GL nearest, but it's not texture wrap. This is GL texture mag filter and min filter. And if we are blended, we want linear. All right, so once we've done that, we can actually now use the GL text image 2D function. This will allow us to be able to use this GL text image. So GL texture 2D, and that's our target. Specifies the target texture, and then so now we want to do the level. The level is going to be 0 level, and that is the level of detail. 0 is the base image level. Then format. So what is our format? This is our internal format. The number of color components. Width. This is the width of the texture image. Then you'll have height. And then we'll have border. This is always 0. And then format again. This is the format of the pixel data. Now we want to put in the type of data, so that's GL unsigned. Oh man. Byte. Type. The data type of the pixel data. And then the data itself. And the data is the image. Okay, so once we have created our texture, we can now free that image from soil or delete the image data. And we do that by calling soil free image data and just send in that data. And then if we make it here, we can return true. All right, that's our load function there. So now we can come down here and right before our vertices, remember this is all just temporary, so we're just going to temporarily load texture, and then we need to create the texture ID. So first create the texture ID and gen/bind the texture. And we create the texture ID, just GLUint text ID, then GL gen textures, and that's 1, and we send in the texture ID. And then we want to go GL bind texture, and then it's GL texture 2D, because that's our target, and then we have to send in our texture ID. Then create a width and height for the texture. So just int width 0, height 0. Cool. So now we can load the texture. So we just go if not load texture, and I'm gonna have a folder called assets. I'm gonna have a folder called textures. This is all for testing, and then I do have one called castle.png. And then we send in the width with it, the height, and false. I don't want this one to be blended. So std cout fail to load the texture. And we'll just exit if it doesn't work so we can figure out why. So let's quickly do this if you want to. You can load it from wherever you want, just make sure your path is correct. But for me, I'm just gonna open this up here. Just go to add, new folder, assets, and in that I'm gonna add another folder. That's just gonna be textures. And then I'm gonna go over to that. Go to my editor, assets, textures, and then I'm going to grab my file that I have somewhere else and just change that to castle. Cool, so that should be there. So now we have our texture. This is what that texture looks like. It's a little texture tile set that I have for making a castle. It's called castle. As you can see, these are 16 by 16s. So right now, we're just going to try to load this and make sure it loads. I'm going to put a breakpoint here, and we should get to there if it loads. We're not using it yet, but we'll see if it loads correctly. Yay, so it got there. That means it loaded the texture correctly. So let's quickly look over. Yeah, so see our texture ID is 1. And then if we highlight our width, 512, 512. That's perfect. So it loaded it successfully. So now let's fix our vertices. We can just stop this. We don't need to see anything. So we can just fix our vertices to now hold on to those textures. So now that we loaded the texture correctly, we need to add in the UVs to the vertices. If you look at the UV image again, here you can see that the top left is 0 and 1. The top right is 1 and 1. The bottom left is 1 and 0. And the bottom right is 0, 0. So we'll put that in right now. Top left, 0.f, 1.f. Top right, 1.f, 1.f. Bottom right, 1.f, 0.f. Bottom left, 0.f, 0.f. Awesome. All right. Now that we put that in our array, we must add it to our shaders and then into our attributes to be used. In our shader, we're going to need a new in vec2 for the new texture coordinates and a new out vec2 to send to the fragment shader. So here, we can just copy this line, change this to location 1, and it's going to be in vec2, and we're going to call this a text boards. And then we also need an out. Make a new line here, and then go out vec2, and we'll just call that frag UVs. And we can do that right here. Frag UVs is equal to a text boards. Now those are the text chords that we're sending in. And then this will be going to the fragment shader. So let's go to the fragment shader. So now in our fragment shader, we need to use the out from the vertex shader as the new in variable. Along with our vec4 color, we also need to use a new uniform Sampler2D for the GLSL language, and we use it with the texture function. So we will just comment out the color for now, and then use the color as the texture, and then we will add the other color back in later. So this is what we do here. So we go keep our out, but we can go here, go in, vec2, frag UVs, and we'll just comment out this whole line for now. And go color is equal to texture, U texture. But before we do U texture, I need to go frag UVs. So what's U texture? We need to add U texture here, and that's a uniform U texture. So that's a sampler 2D U texture. And that's the texture right now that's currently bound at texture 0. So now that we have adjusted our shaders and vertices, we must now link the new vertex attributes so we can actually use the texture. We'll also have to change the stride here. The stride is now 5 floats. So right here, if we come down here, our stride is no longer 3, it's 5 floats. So let's go back up here and you look at our vertices. So this is 1 vertex, and it's 1, 2, 3, 4, 5. So that's our stride now. So down here, we change our stride to 5. Now we have to do the GL vertex attrib pointer for our UVs. So where's our attribute going to be? It's going to be at 1, and its size, it's 2 floats. So that's GL float, GL false. Then we got our stride, so the stride is the same as this. And then our pointer is going to be different. It's going to be reinterpret cast to avoid pointer, size of float times 3. So this is the offset of the positional data to the first UV coordinate. And then we have to enable the new attribute. GL enable vertex attribute array 1. So once we have that enabled, we can come down here, right here, we don't need this anymore, we can get rid of that. We can activate our texture, and we do that by going GL active texture is GL texture 0. We don't really need to do this one because the default active texture is texture 0, but if you're using multiple textures, it needs to know which one you want. Then we want to make sure that we're bound. So GL bind texture. The texture should already be bound. We're going to do it again. So GL texture 2D. And that's a text ID. So we need to send in. And that should work. I think I've got everything. Let's see what happens. Okay, so we're missing some stuff here. So we failed to compile the vertex shader. Let's go back up to it and see what we're missing. Yeah, right here. Try again. Fragment shader, undefined variable, frag UVs. That's because I put a small s there. Actually, I like a small s. Let's go here. Yeah, right there. Yay, we got our texture. If you see, our texture is upside down here because the texture, when it was loaded in with its value starting top left, starting with our 0, 0 and going downwards. But OpenGL expects it a different way, so it will map it upside down. There's a few ways you can deal with this. So one of the ways to deal with this is to swap the vertices up here. So if you swap the top left and the bottom left, and the top right with the bottom right, that will work. You can also, when you load it, you can swap your image values in here. Now, Soil doesn't have the invert Y, but there's a little function that you can just do a double for loop here and swap all your values. So to swap the values, we can just do this here and go, let's just copy this and comment that out. And then we'll just say, this is the swapped text chords. So to swap the text chords, we'll just take the bottom or the top left and switch them with the bottom left, top right, switch it with the bottom right. All right. So if we run that, it should be flipped the right way. Yay, so our texture's flipped the right way. You can also flip using projections, but we won't get into that right now. All right, so that's long enough for this video. So if you want, go back to the slides and look to see what we did for the generateUVs. Create a struct and then change these values. Grab those functions and the lambda function, put those in, create that struct, and then change these values with your UV values. And see if you can get it to be the small pieces here. See if you can load just a 16 by 16 or a 32 by 32 part of this image rather than the entire texture. So go back to the slides and try to type out the function yourself. See if you can do it. It's all there. It should all work for you. And if you have any questions, post it in the comments below. Also, I'll go over how to do that in the next video. In the next video, we'll also start to try to look into a simple camera projection, just a simple one, before we start separating everything into their own classes. All right. Thanks for watching. I'll see you next time.